Okay, so what we're looking at is the Section A core. So we're looking at data analysis and we're looking at the first question. Okay, so we've got a table looking at some information about cities, congestion level, size, and increase in travel time. And those are our 4 variables, and those are stated here. Okay. All right, and basically that data I just skimmed through there. It looks at some traffic congestion stuff on an impact on traffic congestion on travel times on some cities in the UK. Okay, so I went through those 4 variables just before. So the first question is, how many variables in this data set are categorical? Now remember, we've got 2 types of data. We've got numerical and categorical. But because we're looking at categorical, let's remember that is when we look at categorical, it's looking at qualities. So it's qualitative data. And when we're looking at this, we're looking at, so qualitative, it's not looking at the numbers and represents quantities. So when we look at this, we can see that city is categorical because it's a qualitative thing. We can look at congestion level, and then it's qualitative. Okay, because we're saying it's high, medium, low. We're not giving quantities, so that's another tick. Size of the city, again, large or small, same deal. It's a qualitative measure, and so therefore we've got 3 so far. Increasing travel time, we're looking at a quantity here. So this would be numerical. So this would be not one of those responses. So the answer to this one is 3. Now, in an exam, make sure you do that quicker than I just did then, but that's how you can actually do that one. All right, how many variables in this data set are ordinal? Now, if you remember, ordinal data is data with ordered qualities. So for example, the name of the city, there's no order to it. So cross that out. Let's get rid of these ticks here. We know this one's not going to be part of that. Congestion level, that's got some order because we're going from high, medium, low. So we've got an actually order to it. So I'm going to tick that one. Size, large or small. Again, there's an order to it. So it's either large or small. There's some sort of ordered quality. So we're going to tick. And therefore, how many of these variables are ordinal? We're going to go 2. Okay. So the next one, it's name the UK cities with medium level traffic congestion. Okay, so for that one, medium level tracking. So let's go here. Name the large UK cities. So key point here is large because I nearly forgot to do that, with medium level traffic congestion. So that means we need. Let's have a look how they've done this. So let's look. So it's the congestion levels ordered. So I will look in this case. It was medium level. Okay, so those are the options I've got, and I want the size of the city now. So do this one first, do this one second. Okay, so now I've got large, so it's this one and this one. So in this case, your answer will be Newcastle, Sunderland, and Liverpool. So Newcastle, Sunderland, Newcastle, Sunderland, and Liverpool. Okay. All right. Use the data in table 1 to complete the following two-way frequency table from, so we're calling this table 2. So what we're looking at here is we're looking at city size and congestion level. Okay. So in this question, what we've got to look at, we've got to look at congestion level, sort of high, medium, low. In each of those, pick out this number of small and number of large cities. So let's do each congestion level at a time. So let's go up to here. All right. So let's go here. So high congestion level for the moment. We're going to just look at these ones, and that's said 4, but let's see where we can get it. So I'm just going to cross those ones out like that. So that's where we get 4, and we get 2 large. Okay. So let's go down and put 2 here. Now let's go to, let's just get rid of this so it's not confusing things. So now I've got the medium congestion level. Small, I've got 1, 2, 3, 4 there. and then 1, 2 of the large. Okay, so then we go to, so we're going to put 4, 2 there as well. 4, 2, and then we come back up to here and we do the low. Let's highlight that. And so small. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And then for the large, I'm just going to go 1, 2, 3. So we've got 8 and 3. Okay. That's all you have to do for that question now. Well, close to that. So there I'm just going to do the totals. So you can see 4 plus 4 is 8 plus 8, 16. So yes, we got the right answer there. 2, 2 and 3 would give us, so that's 4 and 7, 3 is 7. So that's what our answer is there. All right. Next question says, what percentage of small cities have a high level of traffic congestion? Now, the key point to this is we only want to look at that. We're not looking at all the cities, because that would be 23 cities. We're only looking at small. So that's what's going to be our denominator, basically. So our denominator is going to be 16. Okay? In this case, we're looking at high level. So therefore, I'm going to put a 4 there. And if I do that and convert it to a percentage, it's going to be 25%. Okay, so the key point with that is focusing in on the small cities and then look at the high level part. Okay, that's the key point. All right. So next question. Traffic congestion can lead to an increase in travel times in cities. The dot plot and box plot below show an increase in travel time due to traffic congestion in minutes per day for those 23 cities. Okay. Now, describe the shape of the distribution of the increase in travel time. So the key with that is you've got to look at where your data is and where the data is essentially trailing off to. And the data here, is going like that and then going down like that. Sorry, I'm not the best drawer, as you can probably see. So it's going like this. So it's trailing off to that end. And when the data is trailing off to that end, we're calling it positively skewed. Now, as I'm writing that, you can also look at that from your box plot as well. You can see that the data is, remember, this is 25% of your data, 25% of your data, 25 and 25 here. Okay. That means 50% of your data is found in this region here. So you've got all that data and then data trails off that way. So that's another way to look at, you can use a box plot to ascertain whether you've got whether it's a positive skewed, negative skewed, whether it's symmetric, whatever it happens to be. Okay. Question G is the data value 52 is below the upper fence is not an outlier. Now, this one, it's important that in your summary book you have these somewhere there, so in case you forget. Because you remember, upper fence, let's just put upper fence because I'm lazy and I don't want to write upper fence. It's equal to Q3 plus IQR times 1.5. So that's a 1 and that's a 1.5. Now, just as a remember, I'm going to put it down here. The lower fence equals Q1 minus IQR times 1.5. So in a sense, this term is the same here. It's these two parts here that you need to be really remember. Okay, let's get rid of that for the moment. Now, what's our Q3? Let's have a look at what our Q3 is. A Q3 is this point here. So remember, Q1, that's the median, and that's Q3. Okay, so my Q3 is 39. Oops, 39. Let's rewrite that again. plus, now IQR is that difference there. So that's my IQR. Oh, IQR. So that's basically Q3 minus Q1. Okay, that's what it equals. So therefore, I've got 39 minus 30, so it's equal to 9. And so what I've got here is 9 times 1.5. And if you do 9 times 1.5, what you get is 13.5. So I'll go 39 plus 13.5, okay, and that's equal to 52.5. Okay, so that's the answer we're looking for there. Now, strictly speaking, you probably don't need to show all this working out in every step in your exam, but I'm showing just to make it clear where it's all coming from. So therefore, the 52, because it's below 52.5, it's not an outlier. If it was on the other side, if it was 53, that would be classed as an outlier. And you would see a dot out here somewhere. Okay? All right, that's question 1.